Hi guys, with the Keystones approaching, today is working on scatter plots and lines of best fit. So some keys with lines of best fit is a lot of times we think it has to run through the origin or 0, 0. So make sure that whenever you're drawing a line of best fit that you're not thinking that it has to run through this point here, because it does not necessarily have to. Okay? Now, when you're drawing a line of best fit, your goal is to get the line that best fits the data. So this is a scatter plot where we have all the points laid out here, and we want to draw a line that comes closest to hitting all the points and and has about the same number above the line as below the line. And so when I draw this line, you want to draw a straight line, which I'm going to attempt to do to the best of my abilities with this system. It's not too bad, right? If you look at my line of best fit, I have 1 point below the line and 2 points above the line. Now the point that's below the line is about that far off. The points that are above the line are about that far off as well. So we've come really close to drawing a line of best fit. Now, if you look at the question, it wants to know, and this is generally what these types of questions are going to want you to answer, is something that happens in the future or something that happens in the past. And so it says the scatter plot shows the number of CDs in millions that were sold from 1999 to 2005. If the trend continued, about how many CDs were sold in 2006? And so if we just extended this line a little further, now this was 650, that would make this 600, and below that would be where we crossed there, which would be about 550 million. That's important to write that million on the end, because on the keystones, if this was an open-ended question and you left the unit out, they would take points off. So important to write that million on the end there. So scatter plots and lines of best fit, they're pretty straightforward. Let's look at another one where we actually have to make a scatter plot. So the first thing you have to do is know how to plot points. -2, 2. If it's -2 for the x, it means you go back to -2 and up to 2. Pretty sure most of you know that. Then we have -2, 3, -1, 2, 0, 1, 1, 0, 1, 1, 1, -1, 2, -1, 2, -2, and 3, -2. Now, scatter plots and lines of best fit are not an exact science. But I can kind of see a line forming already right there. So that's the line I'm going to go with. I'm going to draw this line that formed already. It's supposed to go through that point and those points. Like that, right? Now I can just look at this line of best fit and come up with an equation for it. So it's y equals, then you have to look at where something x plus something. Now, look at where it crosses the y-axis. Crosses at the point 1. That's what your plus something is. Then look at the slope. It goes down 1, right 1. So if it's down 1, that's -1 over 1. So your slope is -1x plus 1. That's really all there is to it. Now my line of best fit has this one with 1 away. This is about half, half, and half. So it's not bad. All right. Let's move on to the next one. Scatter plot shows the average price of a Major League Baseball ticket from 1997 to 2006. Using the points 2001 and 17.6, 2002 18.75 to write the slope-intercept form for the line of best fit shown in the scatter plot. So The first thing we're going to do is we're going to figure out what this value would be. So those are your y's, they go on top. So your slope is going to be 18.75 minus 17.6, and that's over 2002 minus 2001. The bottom is just going to give you 1, so that's nice. Then if we do the top, 18.75 minus 17.6, it's going to give you 1.15. That's your slope. Now we just have to figure out where that point would go through here. And so we can actually plug these points in. Y equals, now if we're looking at 2002, it would be 1.15x plus b, because we don't know what this number is. Now we can estimate it at like, and that's kind of how I would do it. I would just estimate it at like 12.1 or even 12.5, so that I can then just figure out a number here. You're going to have multiple choice for most of these questions, so don't forget that aspect of it. But we can go 01 with 17.6, and that is the 1, 2, 3, 4, 5th point out. And so you could do y equals 1.15. Now your y is actually going to be what our y value is for 2001, 17.6. Equals 1.15 times 5, because it's the 5th number out, 1, 2, 3, 4, 5, plus b. So we do 1.15 times 5, which gives us 5.75. We do 17.6 minus 5.75. It gives you 11.85. So that's what the estimate would be for this line of best fit. So we know it's not, even doing it mathematically is not as accurate as looking at the actual line of best fit here. So let's just go ahead and mark this off at 12.5. And we'll make that our solution. So it's 1.15x plus 12.5. Use your equation to tell the price of a ticket in 2009. Is this extrapolation or interpolation? Okay, so anytime you are going outside of what your data set is, so 2009 would be way out here, right? That would be extrapolation because you are doing extra points. If it's interpolation, it would want to know, like, in the year 2002, what would it be? And so we would be using the line and our data points, or halfway through the 2002 year, tell us what the ticket prices were. So we will be using the data inside if it's interpolation. In and extra is all you need to know for extrapolation and interpolation. Okay, so to extend this out to 2009, this would be 96. So if we go out, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2007 would be 11. 2008 would be 12. And 2009 would be 13. So it would be y equals 1.15 times 13 plus 12.5. It's going to give us 27.45. So that's what your ticket price would be expected to be. All right, now I realize that your worksheet is messed up. Do as many of the questions as you can. That one corner folded down, but should be okay. All right, guys, good luck.